Well, good morning, all of you. In the previous class, we were discussing about areas of oblique triangle. Okay, we were left with a couple of problems there. I had not discussed one of the formula, so I'll just discuss that particular formula and move on to today's topic, that is irregular polygons and nets. Okay, I want you all to note down this formula. Supposing if I have a triangle ABC and corresponding to capital A I have side small a, capital B I have side B, capital C I have small c. Then area of triangle is nothing but half of product of any two consecutive sides. For example, these A and C are consecutive sides, half times A times C times side of B, because B is the included angle. So area of triangle can also be found by this formula, the product of two consecutive sides times the side of the included angle divided by 2. Okay, same way you can also find the area of triangle using half of B times C times sine A. You can also find using half of A times B times sine C. Okay, I hope you are clear with this. For that, let me do one problem real quick so you can observe. Supposing I have a triangle like this and they just give me these two sides, like this is 6 and this is 7, and they give me this angle as 60, and they ask me the area of this triangle. Then area of this particular triangle is area equals, these are the two consecutive sides, right? 6 and 7 are consecutive sides, so I can take 6 times 7 and the included angle is 60 degrees, so sine of 60 degrees divided by 2. Okay. If you substitute that in calculator, we will have 6 times 7 times sine 60 divided by 2, which gives us 18.187 square units. 18.187 square units. I hope everyone is clear with these kind of problems. Okay, there will be few problems of using this particular formula that you'll have to do on today's worksheet, which will be today's homework. So let's get started with today's topic. Okay, we will see irregular polygons, how to find their areas and nets. Let's move on to next slide. Find the shaded area of each figure. Okay, there are two figures that are given to us. Here they want us the shaded area. Okay, that is it, great. And here they want sum of these two shaded area, this area plus this area. Okay, I want you all to try this, especially the first one. I hope you'll be able to get the first one answer easily, and second one you can try. I'll give you like 3 minutes and then we will go over solution. Okay, on the first one is, the larger one is the rectangle, and we are subtracting areas of two squares from this particular rectangle. So area of, let me call the larger rectangle as R1. Okay, this whole rectangle is R1, this one is square 1 and this is square 2. R1 minus area of square 1 minus area of square 2. Okay, they are squares because they have given all the four sides are congruent. So area of this rectangle is 16 times 10 minus area of the square is 4 times 4 minus this particular square is 8 times 8. So if I further simplify, this is 160 minus 4 times 4 is 16 minus 8 times 8 is 64. Okay, 64 plus 16 is 80. 160 minus 80 is 80. And the units that were there was meter, and this is area that we are having, area of shaded region. Is nothing but 80 square meter or 80 meter square. Okay, let's try the next one. We may have to use the trig ratios here to get the value of RS, RM and NS. So first, they have given ST is 10 and they have given angle R is 45. With reference to 45 degrees, this 10 is opposite and this is your adjacent. RS is adjacent. Okay. So we can say tan 45 is nothing but opposite, which is 10, divided by adjacent, which is complete of this RS. And simplifying further, we can get this RS as 10 over tan 45. Okay. Let's substitute this in calculator. 10 divided by tan 45 is 10. Because tan 45 is 1, so 10 divided by tan 45 should give us 10. We know RS is also 10, which means they have given M is midpoint, so we can say RM equals we know the RM is going to be 5 units. And Mn and Ns are 2.5 unit because N is the midpoint of Ms. So Mn equals Ns equals 2.5. Okay. First, let's find the area of this particular triangle NST. Area of triangle NST I'm just saying area for A, area of triangle NST is half of base times height, that is half of NS times of ST we can do. It's nothing but half of 2.5 times of 10. So you'll have 12.5 square units. Okay, this is first part. Now I need to find this particular area as well. Area of RMT. Okay. I can find RT by Pythagoras theorem because I already have from this triangle RS is 10 units, ST is 10 units. So this is supposed to be square root of 10 square plus 10 square. It's nothing but square root of 200. Okay, I'm just keeping it as square root of 200, or if you want you can write in decimals up to, it is 14.142. 14.142 is your RT. Why I use that? Because I can use the formula to find area of triangle RMT is nothing but area of triangle RMT is half of two consecutive sides that we have, which is RM add RT, type side of 45. Half of RM times RT times sine 45 degrees. We already have the values of RM. We found RM equals 5. RT was given, RT we found as square root 200 at sine 45. So we can just substitute that. Half of 5 times RT was square root 200 times sine 45 degrees. Okay. Just substitute this in calculator, you will get area of triangle RMT. And the area of shaded area is sum of these two. So first let's get this area. Which will give us 25. This is 25 units. And sum of these two is 25 plus 12.5. That will give us 37.5. So the shaded area is 37.5 square unit. I hope these two problems are clear. There are a couple of more, and I'm sure you'll be able to solve these two. So I'll give you like 3 minutes once again. Try these. Problem number 3. You will need area of parallelograms in this case, and area of parallelogram and area of rectangle. Okay. Solve problem 3 and 4. You have like 3 minutes, and after that we'll move on to next slide. Okay. This is missing, so I'm just giving you this base of this parallelogram as 16 millimeter. So use this when you solve. Let's solve the problem 3 and 4. Let me call the larger parallelogram over here as P1 and the smaller parallelograms P2 and P3. Let me relabel this. So I'll call this as P1, this as P2, and this as P3. The area of the larger parallelogram. Area of parallelogram is nothing but base times height. Okay, so area of P1, they have given the base which is 24 and the height is given to us which is 60. Okay. 24 times 16 gives us 384. And area of P2, second parallelogram. Here the height is 8, base is 10. Area of parallelogram is base times height, 10 times 8, which gives us 80. Then the area of third parallelogram that we have. The height is 12, the base is 6. 12 times 6, which is 72. Now the shaded area is nothing but area of P1 384 minus area of P2. We are subtracting area of P2 and P3 minus area of P3. So that gives us 384 minus 80 minus 72. That is nothing but 232, and the units were in meters, so 232 square meter. Look, this was also in meter square. If you want to be, but this will be our final answer, 232 square meter. Let's try this one. On this one, I have two parallelograms. One parallelogram, the larger parallelogram, and this is a rectangle. So area of parallelogram P minus area of rectangle R will give the shaded area. So area of parallelogram here, base times height, which is 60 times 11 minus area of rectangle, which is 8 times 5. So whenever you do these kind of problem, make sure that all of them have same unit. So for here also, the previous one, here also we have to check. If they are not, then we have to convert to the same unit and then solve. Okay, luckily for us, in this problem everything was in same unit. So 16 times 11 minus 8 times 5 is 40. So minus 40 will give us 136. So this is 136 millimeters square. Okay, that will be the area. Okay, let's move on to the next slide. Find the area of each composite polygon. You can use all the concepts that you have learned. Just to give you a hint, you will use half of area times half of apothem times perimeter. Otherwise, let me do one of them and I'll give you a chance to work on the second. Let me do the first one for you. This is pentagon, so I'm just going to call it as P, and this is our rectangle because these two sides are congruent and these two sides are congruent. So area is area of pentagon. This whole area they're asking. So area of pentagon plus area of pentagon P plus area of rectangle R we have to find. To find area of pentagon, it's a polygon. We have a formula which is, I'll just call it, instead of pentagon I'll just call it as P. Half of apothem times perimeter. Perimeter is easy to find because all of the sides are 14 and I can get here perimeter is nothing but equal to 14 times of 5, which is 70. I have this value, perimeter is 70, I know, okay, but I don't have apothem. I need to find the apothem. For that, we got to go to the center once again and we got to get the central angle. The central angle is going to be 360 divided by 5. 360 divided by 5 will give us the central angle, which is 72 degrees. But we are not interested in that 72 degrees, we are interested in half of that. So 72 divided by 2 is nothing but 36. So this angle is 36. This whole angle between the two consecutive uh, sides from the center is 72, but this is 36. And I know this whole thing was 14, and this is like perpendicular bisector that we have when it is 36. This is going to be 7 feet because all of them are 14, so this is 7 and 7. We can use trig ratio to find this particular apothem, which is A. So with reference to 36 degrees, this is by opposite and this is by adjacent. So I can use tan 36 degrees equals 7 over apothem. Further, if I just rearrange, I can get apothem equals 7 over tan 36. 7 divided by tan 36 will give us 9.635. Okay, now we can find the areas very easily. The area of the pentagon is half of apothem, which we already have, which is 9.635 times the perimeter, which is 70. Which will give us 337.214. feet square. That is for area of pentagon. This is area of pentagon. Okay. Area of pentagon was this. Then area of rectangle. That is quite simple. Length times width. This is 22 and this is 14. 22 times 14, which will give us 308. 308 square feet. Now the area of the composite polygon is sum of these two. So the total area adding these two, 308 plus 337.214 will give us 645.214. 645.214 feet square. That is our composite total area. Okay. I hope this is clear. I'll give you like a couple of, I'll give you like 3 minutes on this particular problem. You got to find area of this particular polygon, then area of these two triangles. Remember, you can use the formula square root of s times of s minus a times s minus b times of s minus c for finding area of triangle. For this you can use same formula, half of apothem times perimeter, but you got to figure out this one first. Okay, I'll give you like 3 minutes exactly, then we will go over this solution. Let's go to the solution of this particular problem. I already see answers from I see answers from Yuki. We will check if that is correct. I don't remember what is the correct one. This particular polygon, it's a hexagon and it's an equilateral hexagon, regular hexagon. So we can use the formula area of hexagon as half of apothem times perimeter. They have given us apothem which is 12. They have already given apothem which is 12 centimeters. But I don't have perimeter. I need to find this side. To find that, first let's figure out what is central angle. Central angle is 360 divided by number of sides of this particular polygon. 360 divided by 6 gives us 60. And this is going to be half of the central angle. 60 divided by 2 is 30. So 30, with reference to 30, this is opposite and this is adjacent. I can use tan 30 and get opposite over 12. Further, if I rearrange, I can get opposite as multiplying 12 on both sides, 12 types of tan 30. Okay. I have 12 types of tan 30 degrees, which is nothing but 6.982. Okay, this is the opposite side. But one of the side of this particular, the side is going to be twice of the opposite. Side is twice of the opposite. This is opposite and this also will be of same types. 2 types of opposite if I do, I'll get the side. So 2 types of 6.928, if I do, I get 13.856. Okay. Now the perimeter of hexagon is nothing but 6 types of this number. 6 types of 13.856. Which will give us 83.138. had not rounded in my calculator and I just multiplied and got 83.138, but if you just multiply 6 times 13.856 you will get 83.136. There will be error in third decimal in case you round. Okay, I have just rounded here itself, so I get 83.136. Now I have the perimeter. I have apothem as well, which is 12. So area of hexagon. Half of apothem, which is 12, times perimeter, which is 83.136. Which will give us 498.816. I hope you are clear with this. Then next we are finding the area of the equilateral triangle. I said we could use this formula root 3 over 4 times s square, where s is the side which is congruent to the side of the hexagon, and we found the side of hexagon to be 13.856. So this is 13.856 each of these sides. So area of this equilateral triangle is root 3 over 4 times of side, which is 13.856 whole square. Okay, let's use calculator to further simplify this. Which will give us 83.134. So the total area is area of hexagon plus twice area of triangle. So let me multiply this term. So total area of hexagon plus twice of area of triangle. Those two triangles were congruent. Okay, if you just substitute the numbers, the final answer you will get is 665.083. There might be few decimal error if we have rounded at different places, okay, but you should get 665.08 at least. Okay, and the units were centimeters, so centimeter square. Okay, that's our total composite area. So total area. Okay, I hope this is clear. Let's move on to the next slide. Okay, this is the net of triangle prism. the two triangles in the diagram are congruent. Okay, the two triangles in the diagram are congruent. So these two triangles, there are only two triangles that are given. So these two triangles are congruent. That's what they're saying. And the quadrilaterals are all rectangles. Find the area of the net. And the quadrilaterals are all the rectangles, and they're asking us to find the area of the net. The two triangles are congruent, they said, but yeah, that will be true. This is 9. Go ahead and try this particular problem. You are finding the area of this particular uh, composite figure. Okay, I'll give you exactly 1 second, like 3 minutes for this. Okay, let's see this particular problem. We are finding the area of this particular net. We got to find area of this triangle, rectangle 1, rectangle 2, and rectangle 3. If you just try to align, you'll be able to make out that this particular 14 will align to this particular triangle, as these two triangles are congruent. So this 14 will align to this particular side, and 13 will align to this particular side. So I can find area of triangle using square root of s times of s minus a times of s minus b times s minus c, where s is sum of all the three sides, that is 13 plus 14 plus 9 divided by 2, that gives us 18, and area of triangle is 18 times of 18 minus 9 times 18 minus 13 times 18 minus 14. Taking square root all throughout, we will get 56.921. Next, area of this rectangle 1 is 22 times 9, which is 198. Area of this rectangle 2, 14 times 22, which is 308. Area of rectangle 3, which is 22 times 13, which is 286. The total composite area is going to be twice of area of triangle plus areas of these that we have. So we will have answer as 2 times of total composite area is going to 2 times of 56.921 plus 198 plus 308 plus 286. Okay, let's simplify this. Which will give us 905.842. So total area 905.842 centimeter square. Okay, at least you should have got 905.8. Okay, there might be few differences based on rounding for the second and third decimal. Okay, let's move on to the next slide. This is a net of square based prism. All of the triangles are isosceles and congruent. They have given all the triangles are isosceles and congruent. Find the area of this particular net. Okay, they are asking us to find the area of this particular net. I'll give you another couple of minutes and then we will go over solution. Okay, let's see this particular problem. We'll just drop a perpendicular bisector because we got to find area of this triangle. There are two ways which we can find. There are several ways basically. Either you can use the formula as half of base times height for area of triangle, or you can use find this particular side, then you can use side times side and side of 40 divided by 2. Area of two consecutive sides. Area of triangle where we have two consecutive side and side of angle. But one of the ways will be to find either the side, but the easier one will be to find the height. That's what I feel. So we'll just find the height. With this, it may get little complicated and we may get a rounding error where we will get 239.9 somewhere answer if you just take like this. But let's see if we can find height using tan 20. So we had tan 20 is nothing but opposite side, which is 4, and this is your height of the triangle, which is 4 divided by h. So h equals 4 divided by tan 20. 4 divided by tan 20, we get 10.9 10.99 Okay, 10.990 I get. Okay, so the area of triangle is half of base type side.
Sorry, by the way, you're muted.
Okay, we have h equals 10.990 and we can find area of triangle as half of base times height. The base was 8 and height was 10.990, which will give us 43.960. This is our area of one of the triangles. But there are four of them, so the total area is 4 times area of triangle and we got to add area of square. Okay, that's our total area. So here I'll have 175.839 plus area of square, which is 64, which will give us 239.839. Okay, because of rounding we may have lost something, but somewhere close to this should be our final answer. And centimeter square. Only the third or second decimal we may lose something, but not before that. Okay, 239.83 or 84, somewhere there should be correct. Okay, let's move on to the next slide. Okay, a flower garden is made with a wide decorative brick border as shown by unshaded part of this figure. The inner square planting area is formed by connecting the midpoints of the 12-foot sides of the regular octagon. Find the area of the brick border. Okay, just try this. We will discuss about this in another 3 minutes worksheet. So on this one, the central angle of this particular octagon is 360 divided by 8, which will give us 45, and half of 45 is 22.5. So this angle is 22.5, and each of these side was 12. Dividing by 2, I have 6 and 6. I have dropped a perpendicular bisector here. I can use once again tan 22.5 to get the value of the apothem. So apothem is nothing but 6 divided by tan 22.5 after rearranging, and I get apothem as 14.485. I need the perimeter, which can be found as 12 times of 8. So the perimeter of octagon, 12 times 8. Okay, 96 feet. Okay, we have 96 feet as the perimeter. But to find area of octagon is clear now. I can find area of octagon. We need area of octagon minus area of square to get the final answer. Half of perimeter times apothem. I'm doing 14.485, which will give us 695.28. But to find the final answer, I got to subtract area of square from area of this particular octagon. So the area of square is nothing but the side square. I don't have the sides, so let's find this S. You know the apothep, and once again, if I have one more apothep, this also will be the apothep for this particular uh, octagon. So taking to find the side of square is nothing but square root of apothep square plus apothep square. Okay, because using Pythagoras theorem, two apotheps will be perpendicular here, and if I simplify this, it will give me square root of whatever 14.485 square plus 14.485 square. Taking square root, I will get 20.485. 20.485. You can simplify this in calculator, you'll get somewhere around 20.485. And then you can find area of the triangle, sorry, area of the square, which is side square. So area of square, which is side square, is 20.485 times 20.485, which will be 419.647. Okay. Now to find the area of the brick, we got to subtract this area of square from the area of the octagon that we found, which is about 275.633. 695.28 minus 419.64, which will give us 275.633 feet square. Okay, that will be our final answer. I hope this kind of problems are clear to you all. Areas of net. For the homework, already the homework is posted on the hub, so please log in to hub and check the homework. It's based on the previous class. In case you have any questions, doubt and need clarification, feel free to unmute and ask. Okay, you'll have rest of the class time to work asynchronous.